If they knew who we were, we'd be dead already.
There is a place above 60,000 feet where the sky turns black, and fighter jets operate there by design. Everyone asks how fast they fly. Nobody asks why they fly so impossibly high. The common answer is to avoid missiles. That is only a fraction of the truth. There are 6 separate reasons, each one more surprising than the last. A commercial airliner cruises at 35,000 feet. A fighter jet routinely operates above 60,000. At 60,000 feet, the sky above is no longer blue. It is deep violet, almost black. At this altitude, astronauts can see stars during daylight. The atmosphere is 90% gone. The rules of physics here are fundamentally different, and military engineers exploit every one of them. Fighter jets are not flying this high by accident. Every foot of altitude is a calculated tactical choice. By the end of this, you will understand why altitude is not just where they fly, it is how they win. Start with the most fundamental force acting on any aircraft: drag. Drag is not just a minor inconvenience, it is the single biggest drain on speed, range, and fuel in aviation. The atmosphere is not a uniform blanket. It gets dramatically thinner with every 1,000 feet of altitude. At sea level, air density is 1.225 kilograms per cubic meter. At 60,000 feet, it drops to just 0.1 kilograms. That is less than 10% remaining. Aerodynamic drag is directly proportional to air density. Reduce density by 90%, and you reduce drag by roughly the same margin. The same engine that pushes a fighter to Mach 1.5 at sea level can push it past Mach 2 at altitude without any change to the aircraft. More speed does not require more thrust at altitude. It requires less resistance. The sky itself becomes the advantage. At sea level, pushing past Mach 1 requires enormous energy to break through the compressed air. At altitude, that barrier is far cheaper to cross. At altitude, fighters can sustain supersonic speeds without afterburner, a capability that would burn through fuel reserves in minutes at lower altitudes. Thin air is not a side effect of altitude. It is a performance multiplier that every modern fighter is designed to exploit. Radar does not bend. It travels in straight lines, and the Earth is in the way. A ground-based radar station can see approximately 30 miles to the horizon before the Earth's surface cuts off the signal. Raise that same radar to 60,000 feet, and the horizon extends to over 300 miles, 10 times farther. At 300 miles detection range, an airborne fighter can identify and track an enemy aircraft before that enemy even knows it is being watched. Modern air combat is won by information first, weapons second. The side with better awareness dictates every term of the engagement. Beyond visual range combat, firing missiles at targets the pilot cannot see, only works if the radar can reach those targets first. A fighter flying at 1,000 feet has a radar horizon of barely 40 miles, and enemy terrain or mountains can cut that to almost nothing. Modern air forces use altitude pairing, one aircraft high to see everything, one aircraft low to strike, a tactic only possible because of the radar horizon advantage. A single fighter jet at altitude essentially becomes a mobile early warning radar station, a capability that used to require entire dedicated aircraft. Altitude is not just elevation, it is the foundation of the entire information superiority that modern air power is built upon. An air-to-air missile is a small rocket with a limited fuel supply. Every ounce of that fuel spent overcoming drag is range wasted. Launched at sea level, the AMRAAM's maximum range is approximately 50 miles. Dense air bleeds its velocity rapidly. The same missile launched from 40,000 feet can reach targets beyond 100 miles. At 60,000 feet, performance increases further still. High-altitude fighters can loft their missiles, firing upward so the missile climbs even higher before diving down on the target, converting altitude to kinetic energy. Kinetic energy equals half mass times velocity squared. A 20% speed increase at impact means 44% more destructive energy. A missile that spends its fuel in thin air keeps more velocity for the entire flight, arriving at the target faster and more accurately. Radar and infrared seeker heads on missiles also perform better in thin, cold, dry air, with less atmospheric interference degrading the guidance signal. A missile fired from high altitude has a natural downward geometry, diving on its target rather than chasing it from behind, which is the most inefficient attack profile. Altitude dramatically increases the no-escape zone, the region from which a targeted aircraft cannot maneuver to avoid the incoming missile. Every aspect of missile performance, range, speed, guidance accuracy, and lethality is amplified by altitude. The weapon improves simply by being launched from higher. Fuel is the single most limiting factor in tactical aviation. Every kilogram burned before reaching the target is a kilogram that cannot be used for anything else. At low altitude, a large fraction of total fuel is consumed simply overcoming aerodynamic drag. The engine is fighting air, not moving the aircraft. At 50,000 feet, the same engine uses dramatically less fuel per nautical mile because drag has been reduced by over 80%. Engineers measure efficiency as specific fuel consumption, fuel burned per unit of thrust per hour. At high altitude, this number improves significantly for turbofan engines. Every jet has an altitude where its specific range, miles per kilogram of fuel, is maximized. For most military jets, this is between 35,000 and 55,000 feet. Combat radius is how far a fighter can fly, fight, and return. At high altitude, this number increases by up to 40% compared to low-altitude cruise. 40% more combat radius means targets 400 miles away instead of 280. It means reaching objectives that would otherwise require aerial refueling. Aerial refueling tankers are expensive, vulnerable, and in limited supply. Every mission that avoids tanker support is a simpler, safer, more flexible operation. Stealth aircraft especially benefit. A tanker rendezvous compromises the stealth aircraft's position. High-altitude fuel efficiency reduces the need for these vulnerable meetings. Altitude does not just make fighters faster. It makes them reach farther, stay longer, and depend less on support assets that could be targeted by the enemy. In aerial combat, energy is everything. Speed and altitude are two forms of the same energy, and they can be traded for each other. Altitude is stored potential energy. The moment a pilot pushes the nose down, that altitude converts directly into speed, for free. A fighter diving from 60,000 feet can reach speeds that a low-flying aircraft could never match, even with full afterburner engaged. When two aircraft enter a turning engagement, the one with more energy controls the geometry, dictating the fight's terms from the first second. Fighter pilots spend hundreds of hours learning to manage energy, never wasting altitude or speed, always keeping the maximum reserve for the decisive moment. A fighter entering combat from altitude against a lower opponent has an immediate advantage that cannot be neutralized, only survived. With better radar range, longer missile reach, and more energy, the high-altitude fighter gets the first shot in virtually every realistic engagement scenario. At high altitude, the air is too thin for many close-range dogfight maneuvers, but that is intentional. Modern fighters are designed to never let the fight get that close. An enemy aircraft fleeing at low altitude cannot escape a fighter above. The high aircraft simply maintains altitude, watches, and fires from range. Altitude also provides the ultimate defensive option. A fighter can disengage simply by climbing higher, extending the range beyond any missile's reach. Above a certain altitude, most surface-to-air missiles cannot reach. The high-altitude fighter operates inside a sanctuary the enemy cannot access. Altitude gives first contact, first shot, maximum energy, and sanctuary from ground threats. It is the single most decisive tactical variable in modern air combat. Most people think stealth is about the shape of the aircraft. That is only part of the story. Radar signals traveling upward through the atmosphere are absorbed, scattered, and refracted by the air itself, losing strength before they ever reach the target. Ground radar must fight through the full depth of the atmosphere to reach a high-altitude target. The signal arrives weakened, and the return is weaker still. Radar signal strength follows the inverse square law.
Double the distance, reduce the power to 1/4. At 60,000 feet, the math overwhelmingly favors the aircraft. At 60,000 feet, outside air temperature is approximately minus 60 degrees Celsius. That is the thermal environment surrounding the aircraft. Infrared missiles detect heat contrast, the difference between the target and its background. In minus 60 degree air, even a jet engine's exhaust blends into the cold. At sea level, the same aircraft's infrared signature is dramatically brighter, glowing against warm air, visible to missile seekers at great range. Contrails, condensation trails behind aircraft, are visible to the naked eye for hundreds of miles. At certain altitudes, fighters can operate in contrail-free layers. At altitude, sound from the aircraft disperses over a far larger area before reaching the ground. The acoustic signature at the surface becomes essentially inaudible. Shape stealth, reduced radar return, cold IR signature, contrail avoidance, and acoustic dispersion combine at altitude into a multiplicative stealth effect far beyond any single technology. The atmosphere at 60,000 feet provides stealth properties that no coding or shape engineering can fully replicate at lower altitudes. Physics gives what technology cannot buy. Altitude is the oldest and most effective stealth technology ever deployed, and it requires no maintenance, no special coatings, and no classified research program. Now consider all 6 advantages operating simultaneously on a single aircraft at 60,000 feet. The next time you see a fighter jet disappearing into the sky, it is not climbing away from the battle, it is climbing into position. The altitude was never the destination, it was always the strategy.